Welcome everyone. My name is Joe Lam. I'm based at University College London, and I'm part of the chair on the Improving Transparency Around Linkage Outputs, in short, ITALO interest group. We are a Dare UK funded interest group aiming to improve transparency around linkage outputs. So this is one of our first lunchtime webinar series where we are hoping to create a platform for knowledge exchange and sharing good practices, innovations around doing things a bit better openly and have clear pathways for evaluation. And we'll be touching on a series of different topics. And to start with, we're focusing on creating address-based linkages. On the screen, you can see that there's a QR code for our next webinar, which is on the application side of using address-based linkages, whilst today we have a stronger focus on the methods in which addresses or clumsy addresses are being linked and processed. Do join our mailing list by sending a quick email to ich.italo@ucl.ac.uk, where you will be able to hear from us about a series of other activities, as well as our close partnership organizations in Sprint and UK data linkage community led by Mike. But without further ado, I will introduce our speakers today. So we are really glad to welcome Robin and Mike to join us today. And you would know Robin from really being a cornerstone for the vast improving data linkage services and practices around UK and internationally as the founder for Splink. Robin didn't stop at Splink, and he's been continuing working on, in this circumstances, a new package for linking addresses. And to kick us off, we'll have Robin tell us a little bit about his new project. And straight following Robin, Mike will give us an exploration of his work at SERP, where he looked more closely in evaluating several different algorithms in matching addresses to UPRNs, or unique property reference numbers. So we will be taking questions at the end of the two presentations, where we can all join in one discussion. But meanwhile, do drop your comments in chat or in Q&A. And without further ado, I'll stop sharing and I'll pass the stage to Robin.
Thanks, Joe. Could I just check how many minutes I have for this?
Anywhere from 20 to 25, but could be shorter.
Okay. It's a bit shorter, but I'm there's quite a lot to discuss, so I'm happy to do questions and stuff. Okay, I presume everyone can see that. So thanks for the intro. So yeah, I'm a data scientist. I work at the Ministry of Justice. My main work is on building Splink, which is an open source project for record linkage at scale. But today we're going to be talking about UK Address Matcher, which is an open source address matching library, which we recently released as a 1.0 and have been starting to use. So just a quick overview of what I'm going to talk about today. So we'll just start very briefly with what this project is, the methodology, but this talk is going to focus a bit more really on how to measure performance and some of the limitations and challenges of that. And I'll do a very quick demo at the end, since I do have time, just to show kind of how we can use the tool. Okay, so let's talk about what this tool is. So I think I want to start with why did we build a new tool for address matching when a bunch of address matching tools already exist? And I think really what we wanted to do is address some of the pain points with existing tools. And we also wanted to see to what extent the expertise we had in data linkage from working on Splink would translate into address matching. So it was a bit like a hypothesis of if we use probabilistic record linkage in Splink to do address matching, how does that turn out? And I think that the features we were aiming for, or I think we've hopefully managed to deliver, are the first big one is simplicity. So this is just a Python package. There's no complex infrastructure to install. You don't need a separate database or anything like that. It's just Python code that you can run on your laptop, or you can run in the cloud, but it should basically run anywhere. Deliberately targeted to be as fast as possible. So on my laptop, I can match about 100,000 addresses. So that's fuzzy matching rather than just exact matching them in about 20 seconds. but really important for us is accuracy. So we publish accuracy statistics against large-scale, publicly available labeled data sets, which is to say that like our accuracy statistics are reproducible. So that means it's straightforward to compare our accuracy against other tools. Now, the only caveat for that, in order to reproduce it, you do need to have access to address base, which is this commercial product, and that's like something we can't easily solve. But we at least put the labeled data out there so that people can run the matching themselves and get the same results. Another couple of important features, support for Ordnance Survey data. So we provide a tool that handles the process of like downloading and processing Ordnance Survey address data, which is like quite a common pain point. So when I say support for Ordnance Survey data, the reason I say that is that our tool is very generic. It can just link together any two data sets of addresses. It doesn't have to be Ordnance Survey data, but we try and make it as easy as possible to work with Ordnance Survey data because we know that that's what most people are doing. And then the final thing is that the whole thing runs locally on your laptop, so no data leaves your machine. So if it's like sensitive data, you can run it in your own environment, and you don't need to worry about like giving other people data. So I'm not going to talk about the methodology in detail today because it's very deep, and I could go on about it for ages, and I'm very happy to take any questions on it. But the key point is that we're using a kind of like ensemble technique. So we're combining probabilistic linkage implemented using Splink with a few other strategies. And we've deliberately implemented, we've almost like constrained ourselves a bit, much like we do in Splink, by implementing everything in SQL. And in doing so, it means that you can execute it using DuckDB, which is like a SQL engine. And that's basically the key to making everything run fast. And it like parallelizes. So if you have a big computer with loads of CPU cores, it'll go faster and all that sort of stuff. If you're interested in more about the methodology, there's a blog post which is on this slide, which goes into much more detail about the methodology. Right, so let's talk a bit about performance. So this is it's been so difficult for us to even like know how to describe performance, and I think like obviously different tools have different performance characteristics. And when we look across address matching tools, I actually think like the real gap in the market here is the lack of an easy way for people to compare how different tools perform on exactly the same data. Like it's really hard to do a fair head-to-head comparison. Like if I did the same thing in my tool, would I get the same results? Would it be worse, better, whatever? And I think what we're really looking for here is for users to be able to make informed decisions on which tool to use. And that's just the hard thing at the moment. So like obviously everyone wants their tool to be as fast and as accurate as possible. But I actually think this problem of comparability is just as important, if not more so. Because if we want to like progress the state of the art in techniques and what works, we're not going to be able to do that unless we can confidently talk about which methodology gives the best results. And I think that that's particularly important because like this isn't a closed question, like what's the best methodology for doing this? Like nobody really knows. And I think I can say that because when you look at all the different tools out there, everyone seems to use a different methodology. So I don't think there's a settled question of like how to do this best. And like that's kind of why we end up using an ensemble methodology, because it's like no one methodology seems to be the best thing, right? So I don't think there's a consensus on what methodology is best. And I think that's partly because it's very difficult to compare different methodologies head to head. So if we're talking about like how do you start thinking about this head-to-head comparison, I think like part of the problem there is like what do we mean by that? And I think the problem is you can't boil performance down to like a single number. I think probably the relevant metrics are something like accuracy, by which I mean precision and recall. But then there's also an element of like speed, like how fast the thing runs, and another one being ease of setup and use. So there's like different dimensions to this problem. And like if you're thinking about this from the perspective of an end user trying to choose an address matching tool, I think like what I'd want to see is a tabulation of those metrics against each address matching tool to make that decision. And then like some people will be like, well, I just want a fast tool and I don't mind so much about accuracy. And other people I want optimum accuracy. It's a very valuable problem I'm solving. So I'm happy to spend a few hours setting everything up. You know, there's a real spectrum here of different user needs. Okay, so to this end, we do publish accuracy information against all of the dimensions I just mentioned and against these publicly available labeled data sets, which we'll take a look at in a minute. This is in our our documentation is at this URL, and this is actually the part of the website you're seeing here, where you can see that we're publishing like how long things take. You can see precision and recall curves, which we're publishing against our data sets. And it says like where you can download the data sets from and that sort of thing. So we're trying to do our best, and it's still work in progress to like publish our side from this. But I really don't think that this is job done quite yet, because like there's a lot of challenges in measuring accuracy that aren't apparent from just looking at the nice precision recall curve that you can see here. So what are these challenges around kind of measuring accuracy? I think the most obvious one is that high quality labeled data is really hard to find, if not impossible. Certainly we haven't found a single data set yet where we're like every single one of those labels we trust. We have found some pretty good ones, but the labels are never 100% correct. So if you look at some of the like tools which I think are like at the forefront, things like Assign is really good, ONS Aims is good. I think a UK address matcher seems to do pretty well, like same ballpark accuracy. I wouldn't be able to say across those three tools which one is the most accurate and which one is the least, for some reasons I'll mention in a minute. But it feels like they're all like roughly similar ballpark. One of the weird things is when you look at some of the better quality labeled data sets, I think the stats come out that they're all about 99.5% accurate against those data sets. And it's like, that's weird. Why is everyone sort of getting the same result? And this is a bit of a hypothesis. I know we see this against our labeled data set. I'm not so sure about some of the other quoted stats. But when I look at that 0.5% remainder of the ones which are false positives, it's actually a mix of false positives and mislabeled data. So there's noise and signal. And it's not just that there's mislabeled data, that there's also a few more fundamental problems that you get. So you get some cases where multiple UPRNs map to precisely the same address string, right? And so the concept of a label in that case doesn't really make sense, because like if there are multiple UPRNs for the same string and you know which one is the right one, well, there isn't really a right answer there. And so those particular ones are not useful for measuring accuracy, and probably it's not a good idea to include them in a labeled data set that you're using for measuring accuracy. So basically you end up where I think you often end up with basically too much noise in the labeled data sets to be able to get you like beyond about this like 99.5% in terms of like you run an experiment with a different technique. Does it make it better or worse? But at the moment, all of that noise is preventing you being able to be really precise about whether it made it better or worse. So we've got this problem with accuracy around the fact that some of the labels aren't necessarily correct. But then another thing is when you're looking across tools, if somebody publishes an accuracy statistic of like 99.5% or something, you really need to know about the characteristics of that data set. Because accuracy varies wildly by the type of data. Like business data seems to be much harder to match than residential data. That's a fairly obvious one. But there's a whole bunch of stuff. So like if you know that your messy data comes from a particular local authority, then you can match it to only data from that local authority. And obviously that's an easier matching task because there's just fewer collisions. Like, there's only one high street, maybe in a small geographical area, but there's lots of one high streets across the whole country. And also just like the general thing, how is the messy data collected? Does it contain a postcode? How accurate is it? So there's just all of these different dimensions that mean that if we want to compare accuracy, we really have to be doing it against exactly the same data set. Okay, so what are I mentioned these publicly available labeled data sets. So what are they? So 37 councils have released their council tax registers as open data. And what I mean by that is that that's by messy address data, I mean address data that is not in Ordnance Survey canonical format, right? It's just a different form of the address string. So it's that address data, but it has the UPRN attached, which is the label. And that's the thing that you can use to measure the accuracy of your address matching tool, because you match the messy address data using your tool, you figure out what UPRN the tool found, and then you compare it to the label to get your accuracy stats right. So there's 37 of these, and each one, like some of them have got 100,000 rows. So this is like a really nice, rich source of data that we can use for this purpose. In addition, actually, I'll just mention one other thing about that data, which is that it comes from a variety of different like geographical areas. So for people who have done address matching, you'll know that if you want to match some inner city London data, that's going to be a lot harder to match than some rural area, because the inner city London data has like apartments and all sorts of like nested addresses, because the population density is so much higher. So you have a nice range there. And another thing that you have is at least one data set from Wales and one from Scotland, which have the UPRNs attached. And that's another thing that we're often asked, like, how well does your tool perform against Welsh and Scottish data, because the formats of the addresses are a bit different. So you get a nice range there, but of course it's all residential data, and it's all like, I guess, somewhat similar because it's all council tax data. The next thing is that some councils include UPRNs in their open business rates registers. So an example is Mid Sussex District Council. There's a URL there to get that data. But again, it's data in the same format. So it's a messy business name and address, and then with the UPRN, they think it is, and again, open data that you can use. And that again gives this nice like alternative end of the spectrum, because the data is much more messy. It's business data, so it's a very different type of data that we can use. We can use for accuracy analysis. And so between those two sources, it's, you know, it's not perfect in covering the full spectrum of all addressing data, but I think it's a pretty good range now that is actually like a pretty valuable source of data. So just moving on, so that was like the challenges around accuracy. Just very quickly talk about the challenges of measuring speed. Even this is very difficult to interpret when somebody says, you know, like, I made the claim it takes like 20 seconds to do 100,000, but there's like so many different dimensions to this, right? So one of them is like, well, how good quality was the address data? Because if your 100,000 records had 95,000, which were very high quality, and exactly matched the Ordnance Survey address string, then you can skim those off like trivially in no time at all. And so it's not really saying anything to say that you match those really quickly. So clearly the worse quality, the messy address data, the longer it'll probably take to match. Obviously, you've then got the computer spec, that's relevant, but another thing that's relevant is like whether it parallelizes. So the question of like, if you make the computer bigger, does the thing go much faster or not, is relevant. Another important thing is like the initial setup, like how long does it take for the initial setup step? So sometimes there's this thing where you have to like download the whole of Ordnance Survey data, do feature engineering on it and all of that sort of stuff. And maybe that can take like 5 hours or something. But when you're talking about performance, are you kind of assuming that 5-hour process has already been done or not? You know, there's that element to it. And also there's a speed thing about like, does the application support real time versus batch, which is to say like, if you submit a single address to it, so I said like I can do 100,000 in 20 seconds, but does that imply that I can do one in like 0.001 second or not? So is it a real time or batch tool? Okay, so just moving on to a few conclusions. I actually think this is a really exciting time to be doing address matching, because some of the data sets I mentioned like are fairly new. They haven't always existed for people to do this sort of accuracy analysis. I think we've got several really good tools out there, and I think we're now making pretty good progress on the ability to sort of start comparing them head to head. And as I sort of mentioned earlier, I think the critical point is this ability to do comparisons head to head, I think is really critical to progressing the state of the art here. And this just feels like a super valuable thing to do, because there are so many like high value applications out there for address matching that if as a community we can get this right, I think there's just so much value to be added by making these tools more accurate and better. On methodology, I think it's really amazing to see the main people doing this going down the open source route. I think that's foundational for all of our success, and it means that we can learn from each other, which I think is really nice. And it's been really nice to be able to actually like really dig into the details of everybody's methodology and like come to this conclusion that like nobody has like this really killer technique that does everything. Like it's all like people trying heuristics and working out what works, right? So I think all of this just represents a really nice opportunity for us all. And if we can really like nail down what works best in different scenarios, I think we can deliver a lot of value here. So I will just show you the very quick demo and then finish because we have time. So this demo is just a really quick demo of what we're trying to achieve with UK address matcher in terms of simplicity and speed. And don't worry if you're not following exactly what's going on. The real point is that the video is about a minute long. So I'll play it as I talk. So in this video, I'm demonstrating the process of matching some data completely from scratch. So I'm starting using a UK address matcher. So I'm starting with a blank folder. There's no software installed. I'm literally going from almost like a blank computer here. And all I start with in the folder is a CSV of 100,000 messy addresses from one of those open data sets that I mentioned. So in this case, it's Hackney Council Tax Register. Importantly, I didn't pre-download any data. So I didn't pre-process any Ordnance Survey data for this. All of that's happening in this video. There's no external database or other services running. It's literally going from like a fresh start. And all of it's working on the laptop. So in the video, what's going on here is I first use our Ordnance Survey Builder tool to download the relevant data set. That goes off to Ordnance Survey and grabs the relevant address data for the Hackney area. It then runs the matching code, which computes all the data cleaning and feature generation needed and runs the matching. And as part of that video as well, it also downloaded and installed all the software needed to make all of that work. So you can see that whole process takes about a minute. And I think that's one of the real key aims of what we were doing here is we spoke to a bunch of people in places like local councils. Most of them address matching isn't their main thing, but they do have messy addresses and they just want to match them quickly and easily. And so this video is a sort of an attempt to illustrate what we're trying to achieve with the UK address matcher, is just making this whole process a bit easier for people. Okay, I'll stop there, but thank you very much for listening and happy to take any questions at any point. Thanks, I'll hand back to Joe.
Wonderful. Thank you so much, Robin. I'll ask people to hold your questions, hold your burning thoughts, make some notes, and then we'll come back to a discussion after Mike's sharing. So I hand over to Mike.
Thanks, Joe, and thanks, Robin, as well. A lot of the points might be similar because obviously we're talking about a similar kind of problem. I hope we can see the screen and the shared slides. Yep. Okay. So I'm going to give a bit of an overview of some work that's gone into the Sale Data Bank and the security research platform to kind of move towards this more transparent and open kind of UPRN retrieval, as Robin kind of alluded to, this open source movement and kind of transparency that ITALO is kind of spearheading as well, has really kind of benefited a lot of us. And I think this is kind of where we're coming at with this piece of work. There you go. So I'll give a bit of an overview of the kind of context and the motivations behind the work, obviously. And then I'll go into the history behind kind of how a sign has come about and what has led this to be carried out. And then I'll go into a bit more detail on the algorithm. I understand, Robin didn't go too much into the detail of the algorithm for the address matcher, but as a nice context, I'll give some insight into how a sign is working under the hood. And then I'll, again, look at its evaluation against the kind of data set that we had available to us. And so as Robin's kind of mentioned, the address data is kind of notoriously difficult to work with. You might have really clean addresses, you might have really dirty addresses. You can't always know what you kind of get based on the data source. And really the range of problems that you can see are quite vast. So it could be just differences in how you actually represent the address itself. When you say address line 1, at what point does my address get chunked up and compartmentalized? Similarly, as was kind of touched on, localization differences. So for Welsh addresses, there's not only the fact that the city or the town might have a Welsh equivalent. There's the fact that the house names and naming conventions differ, and tenements in Scotland and things like this. So for my example, my house name is actually 3 words, and the first word is a single letter, which is often stripped out of these kind of matching algorithms. Secondly, kind of touched on whether it's residential versus commercial. Those tend to be the kind of main ones we focus on, but there are many more classifications throughout sources like ABP that you might want to kind of consider. There's an interesting point around the method of collection and validation and whether it's kind of verified and validated at source. We've come a long way in the recent decades, not even years, but decades to move towards kind of at source validation. But obviously that depends on kind of who's collecting that data and what its purpose is as to whether they have the means to perform that. And there's also other kind of human-centered factors around the actual data itself, whether it's actually updated at all. My address, for example, at my dentist is still the one I had when I was a student, so not ideal. But also missingness of certain components and whatever it may be. So, for example, what happens inside Sail is that we use a trusted third party to kind of process our address data. It's all coming from the personally identifiable stuff. We have some structure in our data sharing agreement that says, please provide it in this form, but obviously, it doesn't always come in that case. And they process this data to us, and essentially it's a black box system to us. It's very difficult for us to know how they actually end up with that final kind of UPRN or encrypted UPRN that comes to us. So we want to kind of have this motivation for moving towards it being a bit more kind of transparent. So downstream then, once that kind of retrieval has been carried out, we obviously have a UPRN kind of retrieved or returned to us. And usually that is then processed into a RALF or this residential anonymized linkage field that can be used, or an encryption of that UPRN that can be used by researchers downstream to carry out research and kind of answer those nice questions that they have. The encryption of the UPRN is quite an easy one. We have usually kind of a hashing function with some salt applied to the value to allow us to perform joins based on that kind of key. And then we can use that pseudo-anonymized kind of key to do our analysis. Maybe it's via things like the household units of analysis, where we kind of group all people that have a kind of registration against a specific address. We treat them as a single unit and we see how that household behaves over time, or whatever it might be for our study. And critically, if we don't know necessarily what's gone into this RALF, then it can be quite difficult to maybe get confident insights into our kind of outcomes of our research. So again, this transparency helps to kind of break that down, provide a bit more confidence when it comes to the work that we then do downstream. So Assign itself. So Assign is an open source kind of matching algorithm. It was produced quite a while ago now, back in 2018, and it's for the Discovery Data Service kind of project, and it was in partnership with Queen Mary, and it kind of worked towards an initial focus on NHS kind of addresses, the addresses that you'd expect to kind of come out of NHS systems. It did really well. It had really strong kind of performance metrics, obviously with the caveats that Robin's mentioned earlier, against these kind of two data sets, the council addresses for Wales and Tower Hamlets in northeast London. So it performed really well, and off the back of that project, there's a bit more kind of like refinement and tweaking and updating of rules for Welsh and Scottish addresses over the next couple of years. So Assign itself is, let's say, not as easy to set up as the address matcher, the UK address matcher. It's back-ended by YotaDB, which is a kind of database engine, which is optimized towards kind of search structures, essentially. And this allows us to optimize, first of all, how we represent our source data set in this database, and then have routines to search through that search space to identify kind of possible matches that there might be. So on top of that Yota database, then there is a load of ton of mumps routines to obviously handle the matching process and kind of data structure kind of building process and all the manipulations and the text handling and all this kind of thing. they're all written in mumps, and there's some kind of wrappers and interfaces in recent years to make it a bit more kind of approachable if you're not necessarily familiar with YOTA database or mumps language. I was not when I started this project to bring it into SerpentSail. I learned those, which was an enjoyable experience, let's say. But obviously, Python is my native language, so those Python wrappers have become very useful. And there's a lot of entry points into Assign, so you can make single queries and batch-based kind of queries, as Robin alluded to. You can search in both directions. If you've got an address string, you can look up a UPRN. If you've got the UPRN, you can look up the standardized kind of structure from ABP. But it is ABP focused. So unlike the address matcher, where you've got a canonical data set where you can kind of provide your list of kind of criteria you want to match against, you have to go against ABP. So Endeavour offer this as a kind of hosted service. That's fantastic. You can essentially query the endpoints if you have an account with them and you have the relevant license for ABP. That's all through kind of encrypted channels. That's perfectly fine. But for Sail and SERP, our trusted third-party environment is obviously kind of closed off. We couldn't make use of that. So we leveraged the fact that it was open source to kind of host our own version, which was fine, and building kind of a Docker solution to allow people to very easily set this up without having to go through all the intricacies of setting up YOTA, learning the mumps in coding and all this kind of thing. But it still exposes the same endpoints. You can still query the same stuff. So Assign is, I would say, fundamentally different to the address matcher and to kind of machine learning methods that you might see in other kind of solutions. It's kind of human judgment driven. So there's a huge rule set available to it where it tries to, from a humanistic perspective, understand what logical and reasonable manipulations might have been made or could be made to a given address string to allow it to match to that canonical string. So, for example, you wouldn't necessarily, if I was giving my address, I wouldn't really give you my postcode first, for example, or halfway through the string. It usually is going to be towards the end. And it kind of like handles these manipulations to provide that matching service. So it, first of all, produces the kind of query at the data set to kind of query against, which is this kind of phase 0 where it's manipulating the ABP data to kind of handle what substitutions might be valid or acceptable, what might be allowed in terms of kind of common fixings of like white space and all the usual kind of stuff. And then it also indexes that YOTADB instance to allow for this efficient searching based explicitly on that rule set. So the optimization is with that rule set in mind, and that's how it gets its performance gains. And then at query time, what you would have is your kind of list of strings come in. It applies the same set of manipulations. It allows for the same cleaning to occur, and it sets up this to then be matched against the backend database. And that is essentially this second phase of then the fuzzy matching itself. So it goes through these rule sets kind of in a ranked order, where it's going from essentially the least manipulations are needed through to like the most manipulations needed to perform a match. And that will kind of give you some rough ranking of kind of how confident you should be in the match itself. It returns things like if it's an equivalent match, if it's a child or a parent UPRN, these kind of relationships between UPRNs that exist within ABP. And it will also then give you insight into what manipulations were carried out in order to obtain that match. So these are the match patterns. So it looks at the kind of component fields of the address and will kind of in a kind of context grammar tell you both what the field was and what the manipulation itself was. So for example, is it an exact match on postcode? Did we have to deal with a slight spelling issue? Is it that it was within the sector? Did we completely ignore that the street was different and it's just too far away to confidently look at the street name? Like all of these kinds of things. And that gives you at the end of this process quite a description on the match rule itself. So here's some examples of the possible manipulations that can occur. So for example, certain fields map to other fields. So for example, I might mix up my my building name and my flat name or whatever it might be. I might swap things around. I might completely ignore a field. I might have partial matches or exact matches. And then the output will essentially be JSON like this, with this kind of context grammar that says this is the matching algorithm. And then we can compare between different kind of matching algorithms to see which was most common in this data set. Does that imply that my original data set was good quality? All these kinds of things. So we looked against census, the address fields, and this specifically compared against the matches returned via AIMS. So it's not a ground truth labeled data set, as you kind of Robin has alluded to, but it does allow us to kind of roughly compare agreements between these kind of two approaches. So the vast majority agreed. And then we have a breakdown of those which don't agree. So as Robin kind of alluded to, sometimes we disagreed with what AIMS returned just because, for example, AIMS returned nothing and we returned something, right? That's still a disagreement. We'd have to look into, well, why did we have a return or not? And similarly, we also looked into kind of distance-based metrics as well. So for example, if our two UPRNs are within 0 meters of each other, maybe they, can be treated for a certain use case downstream as the same kind of residence or retrieval. So they're kind of like insightful metrics, but as Robin kind of alluded to, we're still making our way towards like truly comparable metrics between methods. And I'll touch on something in a second with the discussion. So for example, we also looked at parent-child relationships. So of the disagreements that we had between AIMS, the vast majority of them were actually related in some way. One was a parent of the other, or one was a child of the other. And very few of those disagreements were like completely unrelated. Similarly with distance-based metrics, again, like, some of them were 800,000 meters away, which is obviously, probably not the same building. But the vast majority were within a couple of meters of each other, and depending on the use case and how you handle those, might be okay. So in kind of conclusion of the piece of work, we were quite happy that it allowed some openness and transparency. The match results and the match patterns are quite critical to us. Again, looking at the address matcher, getting a Splink response that we can query and look at and say, well, what was the reason for that match is quite a powerful insight. But we still have this kind of underlying thing of, obviously, if we can validate at source, this removes a lot of problems kind of going forwards, but not everyone can make use of that. It's quite interesting, we found, to look at disagreements specifically. Obviously, the agreements you kind of treat as they agree, right? That's okay. There can obviously still be issues in there. But we were kind of focusing our review on the disagreement. And as Robin kind of alluded to, there's metrics need exploring. So for example, instead of just reporting, precision and recall and things like this, are there ways for us to compare between matching strategies if we can get some stratification of what they kind of represent and what those matching strategies mean? For example, the vast majority of our matches were exact match, everything is equivalent. Well, those are the boring cases. We're not really too interested in those. Every half decent address matching tool should be able to do that. So what do they look like for the tricky and challenging ones would be of an interest to look at. And also going on from this, the use of UPRN in downstream linkage, because obviously we work on a person entity kind of resolution, looking at the use of UPRN as quite a high quality identifier, or very strong identifier. Can be kind of tricky if it's not used kind of appropriately. So we found it's been quite good for kind of blocking rules or using for things like Ralphs. But if used in conjunction with things that are kind of covariates, then it's obviously a bit of a problem sometimes. So yeah, I'll leave it there so we have a bit of time to have a chit chat. Citations fine.
Wonderful. Thank you so much, Mike. I'd like to bring Robin back as well, and who I will start with several quick questions to get the engine running, and then I'll open up to the audience in the chat for any other discussions. I want to first start with quick response in agreement, really, with what Robin, Mike, what you've said, and what Sarah has just put in the chat. It's like knowing what the linkage is for, what exactly is that UPRN is representing, and should feed back into how that matching originally should have been addressed or should have been done. Obviously, that is often not quite possible in in a research setting when there's a centralized, like large-scale matching where these information are produced and provided to users. I think we'll go into this in much more detail in our next webinar, quick plug, that will have some case examples where we'll look into exactly this. And I have a quick question for the both of you. It's mostly about finding that common language. I think it's been, emphasized by the both of you that it's great that we will be able to look at the agreement patterns, look at understanding when and how these different methods would apply to different data sets of varied quality, for example. But what's still kind of stuck in my head is this sort of set of language, for example, Mike has used to describe the linkage, comes from the methods of assign, of knowing how the mismatches are. But that method isn't used in, say, a UK address match. Hence, that set of like descriptors of the linkage can't necessarily be, say, reverse engineered to recreate a comparable quality metric for the data set that's been used to evaluate such methods. So it seems a bit circular. It's stuck in the way where the methods and the ways we describe the linkage are sort of dependent to a certain extent, which makes comparison of different methods not quite possible. So just hoping to get your thoughts on this.
So I think it is possible, but whether the thing that is possible is really beneficial and insightful is tricky. We could take a step back and say, well, here's my performance on a deterministic rule set within this model and the probabilistic rule set within this model. But obviously granular below that, as you say, is then completely blown wide open, right? It might be worthwhile looking at it from the stratification of the data set. Can we in some way look at the actual data set quality and stratify that? And then say, okay, this model works on this bracket of problem within this data set in a certain way. But it's already hard enough to get labels of the UPRN. Getting accurate and usable labels of what the problem is with a given record is almost impossible.
Yeah, not much to add there, but yeah, I agree with all of that.
Yeah, certainly. I think something you mentioned, Mike, and I think it's on your blog as well, Robin, in your description of the methods, was that the term you used was distinguishability, I think.
Yeah, that's right.
I had a very similar idea in one of my preprints in sort of to look at which records to target when we have sort of similarly matched records and prioritizing which ones to focus on to clerical review. And that's a similar line of thought as what Mike has said in choosing relevant records for quality assurance, for example, or evaluation. Any chance you could tell us a bit more, Robin, on what distinguishability, how does it work?
So distinguishability is, let's go back a stage. So when we match an address, two primary scores come out of that, not just one. So one is the match score, the match weight, obviously the higher the better, but the second one is called distinguishability. And the difference between them is that compare two scenarios, one where you have a match which has a very high match score, but then the second place match has a very high match score as well, but just a tiny bit below the first one. The fact that there's a second place match which is almost as high as the first one is sort of tipping you off to the fact that maybe you're not as sure as you think you are. Whereas in the second scenario, you have a lower match score, which means that there's like less agreement, but there's nothing in second place, or the second place match is like way below in terms of match score. I've always thought that probably the second one is the more trustworthy match, and like obviously it depends on how high the match score is. But as a result, with the UK address matcher, everything has both a match score and a distinguishability associated with it, which is great, but it does create a problem for the user because it means that you have to make a choice now over two thresholds. And what we found is that the optimal choice of that will depend on the data set, like is it business data, is it residential data? If it'll let me post an image in the chat, yeah, it does. This is a very nice representation of why this matters. So this is a precision, if people can see in the chat, this is a precision recall curve of the same model running against the same data set with a different distinguishability threshold. So in one of them, we're saying we'll take matches which have different match scores, but the distinguishability must be at least 1. Yeah. And then the other one has a distinguishability that must be at least 10, and you only chose those. And what you can see is with the orange one, that's where you're only keeping the ones with distinguishability of at least 10. So you're rejecting anything that doesn't have really good distinguishability. And we can see here, as you would expect, you get higher precision, unambiguously higher precision, by taking only the ones with high distinguishability, which is a good thing. But you also see that your maximum recall, so the maximum number of ones you can match, reduces. That's why the curve ends at whatever it is there, 80% rather than 90% or something. Because you've deliberately said, I'm not matching any of the ones which have distinguishability, but like 9.9 or 8 or anything below that. And so that like makes the choice here very stark, right? That you have all of these like things that you can configure, but it's not necessarily obviously what the right choice is.
Well, thanks, Robbie. I think we should definitely chat a bit more about this in another setting, because this has direct implications for a lot of the existing practice, for example, in NHS England, where when there's a certain assessment of a distinguishability, and where two records are deemed to be ambiguous, none of the records are returned to the users, for example, as a means of preventing false matches in that case. But whether there are better ways to find a line.
So this chart is also really interesting because it shows that distinguishability matters, but it matters much more for the ones with lower match scores. Yeah. So where the chart basically converges to the left-hand side, that's saying if you have a really high match score, even if the distinguishability is low, doesn't make a difference. It's almost certainly the right match, right? Yeah. So it's a very nuanced picture that comes across about like what the rule is of what settings to use here.
Amazing. I'm being a terrible chair, so I'll open up the question time for everyone. Please do raise your hand or use the chat or the Q&A function if you have any questions. Yes, Tony.
Yeah, if I can just jump in. So I guess just going back a little bit to like UPRN and what UPRN actually represents as I think it's a deliverable location, according to the Royal Mail and the Ordnance Survey, and just a bit about is there anything around that? Is it a sensible? Is that the optimal measure? I mean, it's the best we have, right? So I'm not gonna say anything more than not taking away from it than that. But is it a good measure? Is it a good label? In some sense, is it? If we were if we were starting from scratch, is that what we'd produce?
Personally, I think so. It's very good quality. There are kind of inside the actual source data for address-based premiums. So we know there's some issues with duplicates or for example, I have a shed down the bottom of the field that has a UPRN for some reason. Presumably a satellite image has picked it up and it's been matched, right? And things like schools, right? Like where the actual kind of reception is for a school and all this kind of thing might be off slightly. So there are issues in it, but I think the benefit that we gain from a very high quality kind of ID is probably a decent payoff.
Yeah, it probably goes back to, I think what it's sort of alluding to is like what I guess what Sarah and Robin and yourself, Mike, talked about is what is it we're after? Because obviously we do have these nested UPRNs. We have UPRNs which exist in, if you attach it to a building, there's other UPRNs within the same structure, or very many, and even not in the case of like flats when we're talking about like just like a single story structure. So it's just like issues around what is it we're trying to get from it. I guess perhaps what we've not really said is why we said UPRN also has, it's a deliverable location, but actually if address-based premium, you have that product, there's an incredible amount of data attached to that about what it is, what this deliverable location is. And I don't know if a sign, I can't remember if a sign originally started off with nursing homes, or although that was there's certainly been early address-based parsing has been around like trying to identify nursing homes and care homes and residential homes, and this just sort of helps with that sort of idea. But yeah.
So the main reason that within Sale and SERP we've gone down this route of transparency is obviously if we can get to UPRN, we can then go back to AVP and pull out A, structured data, much more easy to parse and use, and B, other fields that we weren't necessarily using before for our blocking rules and things like this, so like lat long and all this kind of thing. So for example, Robin, the graph you've shown there with kind of distinguishability, what if distinguishability also had, within LSOA, and things like this, right? And if you can report that metric, and I know as a user, well, I'm only able to use LSOA as my lowest granularity, then I know it performs this way and behaves that way, then fine. Or as Sarah points out, if it's a household project, you need that finer scale stuff. So there's different metrics for different people in different use cases. And as Robin alluded to, like we're slowly making our way towards like a common ground of how we talk about these things.
Yeah, it also points to another of the accuracy issues, which is that the way that you process address space can make quite a big difference to your accuracy, because address space knows whether it's a commercial or a residential thing. It has even more granular things than that. It has like non-addressable locations, like a telephone box or something. It's got all of this stuff in, right? And if you know that you're definitely matching to only commercial properties and you filter all of the other stuff out, you're going to get higher accuracy. So there's lots of like, it gets very like murky, because it's like, is the address matching algorithm working well because you were clever in how you process address space? Is it working well because you were clever in how you expanded out your like acronyms like ST to street and FLR to floor? Is it like a cleaning thing you were doing well, or is it that like the fundamental like matching part of the algorithm that once everything is standardized and cleaned, and once you've got your subset of address-based premium, like and so it's like really hard to work out what's good, basically. Because like I think most solutions have all of these different components, and it's like the interactions are important, and it's just very hard to like work out what's the thing doing the work.
We've got a question from Ludovine. Question to both speakers. Great to see advances to produce comparison metrics. Which, if any, would you recommend to share with potential actual end users of the linkages produced? For example, to include in the metadata for the data sets that's concerned.
Yeah, so I think, so we would, when we started work on this, we were trying to make a big table of all the tools out there to work out what the best ones were and work out how you tabulate it to allow it to be compared. And so I think, I'm just reading the question. Like to me, like it's like essentially simplicity, speed, and accuracy is what I'm after, in order to compare the method. And it's always interesting to know a bit about the method. Sorry, I'm not sure if that completely answers the question.
If I reword it a little bit, I think the question comes from the angle of users when they received a set of data set that were being linked by, say, a sign and not by UK address match. And what would they need to know to understand how the process and the data generate processes? And well, to make it more blunt, how can we convince the data owners that it's a good idea to attach these information along with the data release?
So from my perspective, precision and recall, they're the classics. They have a purpose. there is warrant for kind of maybe some kind of agreed stratified description of a performance, but it's not going to be directly comparable. Going back to the kind of multi-model approach, looking at agreements, if I run aims, assign, and ABP against this, and a certain percentage of them all agree, because we're using different strategies and things like this, there's slightly more confidence there. It's kind of how like random forests kind of do their thing by voting, right? So I don't have a good answer. There is an element of kind of trust that the algorithms have been developed in sensible ways, looking at kind of processing techniques that are needed to match these strings. But I guess that's where ITALO will hopefully come in.
We're kind of thinking row by row here. Is that like, I think I understood to be like each row that was matched, what metadata do you attach to that? So one like thing we've come up with is so we've got this ensemble technique, and the first thing it does is it picks off the exact matches, right? And an exact match is defined as it matches the string and address-based premium exactly, and also conversely there aren't two different UPRNs with the same string, right? So you're just completely sure that according to any reasonable metric, that's the only sensible UPRN for that. And so that metadata is very easy to tell the user for that subset of addresses. It's like, well, this is pretty unambiguous. You can trust this, or there's no higher level of trust that you could have in this one, really. It's a complete match. And then if it doesn't go through one of these, and then we've got like a peeled one where sometimes you'll have Hackney London, and sometimes you'll just have London, and sometimes you'll just have Hackney. So it takes like the end of the string and peels it back with some common end tokens, right? And that one I think is like pretty much trustworthy as well, if it's an exact match after peeling. And those don't come associated with a score, right? They just come associated with this when this was matched according to this algorithm. So you end up with this jumble, and it's very tool specific, which is like each pair that comes back is either it says it's exact match, it's a peeled match, or it comes back with a match score and distinguishability, right? And I just like, it does feel very hard to me to imagine how you could unify that into something that was completely comparable across tools at a row, at a pairwise, like row by row level.
Yeah. Well, I think we have it's been absolutely wonderful today that we got Mike and Robin and everyone else that's in the chat. For example, Gail has posted, and to start this discussion in what type of discussion conversation needs to happen towards this vision of using open source solutions to providing UPRN and using UPRN in a better way. There are several other risks and problems we haven't fully covered, like identification, for example, and how that's actually going to be used on the front end in the applied research. So the conversation has to continue. We have a short evaluation form, so this will be emailed to you as well, and along with our sign up for our next webinar. I want to hope everyone will join me in thanking Robin and Mike again for speaking and your generous time, and I will look forward to seeing you all.
Thanks very much, Joe.
Thanks, Joe.
Thank